resend me your answers, but within now, just send me figure A. Let's say the current is clockwise. Okay, or figure B, the current is anti-clockwise.
BI specify in which an induced current flows in the ring كده خلاص.
لا we will solve it, but I mean just resend me the message. انا لسه سكرت زوم اتسكرت من اول وجديد.
نعيد للبي اي وللبي 2 اي.
يس بس مره واحده يعني ابعثوا الانسر let's say figure A او figure B وبنفس الوقت tell me because this it's clockwise anti-clockwise etc. and try to sum the answer within one line. All right. I'm just taking your answers within this time. Okay, thank you. Great. Nice work, Shireen. Aline. Okay, thank you, Aline. Some of you have sent me half of the answer, not all of the answer. Okay, great, Ryan. Okay, great.
بس استاذ determine the direction بدنا نستعمل right hand rule صح؟
Sure, you have to use the right hand rule. Till now I received the answers concerning which figure. Some few sent me if it's clockwise or anti-clockwise. So for the rest who didn't send me the complete answer, if you want to take the full mark, just tell me if it's going to be clockwise or anti-clockwise direction concerning the direction of the current in the figure you chose. Okay, thank you, Amir. Didn't work with you right now with the answer that you gave me. So half of it is correct, the last one is not. Okay, great, Amir. Again, half of the answer is correct, not all of it. Shireen, circuit without E at the end. Great answer, what? Okay, I guess that we can start with the answers. If there is anyone else that is typing his answer, please be quicker. I'll wait 5 seconds and I'll start my answer, okay? Okay, great. Let's start with the first part, part A. Not part A, I mean part B, number 1. So B, I. They said that specify the figure in which an induced current flows in the ring. So most of you said that it's going to be figure A because it's a closed circuit. And it's not figure B because it's an open circuit. So your answer is totally correct. Concerning the next part, so let me just write, too late. It's okay. Again, part I, I'm going to write directly the answer in figure A. Induced current flows in the loop. Flows in the loop. Since it's a closed circuit. The second part, part 2I, the one that we are solving, it's part B. So part 2I, most of you sent or told me that it's going to be an anti-clockwise direction. Let's start step by step. I'm going to ask Shireen to tell me her answer by explaining the results, why it's going to be anti-clockwise. If you can, Shireen, let me know your answer. Why it's going to be anti-clockwise? Go.
It's going to be anti-clockwise since the circuit is closed. I induced will create B induced opposing to B.
Okay.
And according to the right hand rule, I
Mhm.
induced is anti-clockwise.
Rayyan, how it appears with you a clockwise answer, first of all?
Yes, according to the right hand rule,
Okay.
it will if we put the thumb downwards, it will be from right to left, but it is induced current, direction of induced current, then it will be anti-clockwise.
Okay, great, great. Just be sure once you want to provide a complete sentence to explain why the induced magnetic field is going to be opposing the direction of the initial magnetic field. So here, since the magnet is approaching the spring, or sorry, this loop or this ring, then the magnitude of the magnetic field will be increasing. Lenz's law states that there must be an induced magnetic field.
أستاذ
Yes, Danny.
طلع شوابي صح ولا غلط؟
No, you got. Let me check that. I didn't receive any answer from you, Danny.
Ustaz, what about me?
I got the answers from غوى، كمال، شيرين، ألين، ريان، وأمين، من الكل. بعرف عندي داني ما بعت لي جواب.
أستاذ ما بعت لك إياه قبل ما تسكر.
ما رجعت خبرت انه بس عيدوا الانسرز لانه ما وصلون اللي بعتهم اول شيء، ما سكرنا الميتنج. هسه عم تخبرني بعد ما صرنا مخلصين؟ لما خبرتني الاول؟ الله يسامحك. يلا فيك تعد لي الاكسبلانيشن اذا فيك. if you can't then repeat the explanation let me take it from you.
أوكي.
يلا.
أول شيء هي فيجر A لأنه السيركت هو عم بيسك closed.
اوكي.
يعني بيصير في لوب.
اوكي. The direction of the current, how can we specify the direction of I? Are you still with me? If you can tell me how to specify the direction of the current, let me know. Else I will try to specify the details.
أستاذ.
Yes, then I can hear you. Yeah, seconds. Seconds ago.
Anti-clockwise.
Okay, how did you get this answer, Danny? Tell me the detailed specification about this answer. Can you do that? So
according to the right hand rule.
Okay. According to the right hand rule, if we just apply the thumb downwards, you will see that the current will be flowing clockwise here, not anti-clockwise. So how did you get this direction?
لا أستاذ بس I لفوق.
I or B?
Thumb.
Okay, why did you choose the thumb to be up, not down?
لأنه السيركت is closed وهي loop.
Okay, if it's open, so on the right figure, it's open, so the current will be flowing clockwise in this way.
لا.
So complicated, right?
استاذ ما هي open، كيف بده يكون يمشي فيها current؟
I'm not sure about this. I'm just asking Daniel to give me the answer. Sudan, do you have an explanation or it's mixed?
لحظة، it says figure A ولا figure B?
Figure A. You are talking about figure A. I'm just trying to ask about figure B at the same time.
Anti-clockwise.
Anti-clockwise. So the current will be rotating in this way, but why is that? Why is that? Why the thumb is upwards, not downwards, although the magnetic field is created downwards? طول بالك كمال بلش يحل بارت اللي بعده عم يبعث لي الانسر. اوكي خليني نكمل انا ببارت.
فينا استاذ.
It's not the way because I want to be following you step by step. Okay, do you have any?
اكتب.
Okay, do you have anything to add, Danny, before I check if there is any question from Riwa? Okay, Riwa.
Yes.
Tell me.
أول شيء لأنه ال direction is flowing downward.
Okay.
وهو مسكر.
Okay, great.
يعني بده يكون هو لوب وعم يمشي بعكس السيركت، بعكس ال I
Okay.
induced.
I guess I got your answer. Hope that you know the details of this answer, how to explain it in the exam. Okay, right now, if you want to provide detailed explanation within some sentences, we can say that induced current flows. Okay, try to write the answer with me, please. Induced current flows in the loop in a direction such that its upper face acts as a north pole. Why I said this? Since the magnetic field created is directed downward by the magnet, the induced magnetic field will be opposing this direction. So the induced magnetic field will be directed vertically upwards. So till now I said that the induced current flows in the loop in a direction such that its upper face, the upper face of the ring, I mean, acts as a north pole. Okay. To repel the approaching magnet, according to the right-hand rule, I induced flows in the loop in the anti-clockwise direction or counterclockwise direction. That's the detailed answer. If you have any comment, let me know. Concerning the answer, you can write it in a different way. You can just say that since the magnetic field is increasing inside the loop or the magnetic flux, then the induced magnetic field will be opposite to it. So it's going to be upwards. And now using the right-hand rule, I will be counterclockwise. If there is any question, let me know, please, before we move to part C. So this is 2i, and this is the answer of 1i. Now we'll start with part C. Okay, I've received more than one answer for part C. Let me read part C. Part C, they said that the magnet and the ring of figure A are both moving vertically downwards with a speed of 20 centimeters per second. So both of them are moving with the same speed. Does a current flow in the loop justify? I will wait some seconds for the rest to send me your answers concerning part C. So if you have any answer for part C, I will be waiting it. I received some of the answers from Rayyan, Shireen, and Kamal. Okay, I'm going to check these answers and mark them, waiting for the rest. Okay. Thank you, Amir. Okay, Mariana. I know that. Try to answer part C, Mariana. If we have a magnet moving with a speed of 20 meters per second and the loop always with the same speed, do you expect that there will be an induced current or induced magnetic field in this ring? If yes, send me yes. If no, send me no. Thank you, Riwa. Yes, thank you. Okay, I will wait 10 seconds before giving my answer. Three seconds. If you have anything to send. Do it right now, please.
أستاذ
Yes, Danny.
أنت بعت لأفريون بالغلط.
داني انت بعت على to everyone ها؟
إيه عرفت.
Thank you. بس it's okay لأنه كنت بعتها بالآخر منيح بعتها بالأول. بس بتصور الكل عارفين الأنسر هيك. يلا. Great. Let me send the answer for part C. So in part C, most of you told me that the magnet and the loop, they appear to be at rest with respect to each other. So we can say that the magnet is at rest relative to the loop since both of them are moving with the same speed. Since
أستاذ يعني أنا جاوبي غلط
no,
لأنه أنا ما قلت إنه المagnet is at rest relative to the
No,
loop.
no.
أنا دغري قلت إنه they are moving at the same speed.
Yes, since they are moving at the same speed, the magnetic field will be constant.
يعني صح.
Yes.
تعتبر صح انه كتبت لك no speed is changing يعني there is no
Yes,
variable.
yes, I got your point. Yes, it's correct. Since both of them are moving at the same speed, now we can just say that then the magnetic flux is constant. It's not zero, but it's constant. Then E equals to 0, the electromotive force, and thus I induced will be equal to 0. So this is the complete answer if you want. Nice work till now. Do you have any question? Do you feel that this is hard? The exercise that we just solved. If yes, let me know why. Okay, now we'll start with an exercise, which is going to be the last exercise for today.
Yes.
Yes?
بس لا المagnetic flux هي مش زيرو صح؟
Yes, it's not zero, but it's going to be constant.
Okay.
Okay, it's not zero because if we just try to remember the formula for the magnetic flux, flux equals to N times B times S cosine the angle. So the magnetic field is not zero here. And the number of the loops is constant and the area is constant. So everything is constant, but different than zero. But the variation of this magnetic flux is zero. So the magnetic flux is not changing, it's constant. That's why no electromotive force, no induced current. I'm not sure if you got my point or if not.
Yes.
Okay. Now we'll move to number 7, which is somehow more with a higher level. Okay, let me just move downwards to this exercise.
أستاذ شيرين راح عندها النت
Okay. Okay, it's okay. I'm recording the
وما
session.
معها تريتيفر مظبوط.
It's okay. I'm going to record the session. It's being recorded and I'll send the video later on. I'll upload it. Number 7, they said that a magnetic flux through a flat coil. And I will not work with this exercise as marks maybe, but I will choose some of the parts to be like this. The other parts, the new parts, we'll try to solve them together. Consider a flat circular coil C having 100 turns. I prefer that we can just write the given before start solving. So first of all, we know that N equals 200 turns or 200 loops. Each of area 10 centimeter squared. So be sure that we have to change the centimeter squared into meter squared. Just let me take this answer from you to be sure that you can change to the SI unit. Tell me how we can change from centimeter squared to meter squared by a small message. Just write divide or multiply by this number, okay? So do it in a quick way. Tell me how to change to centimeter squared. I will wait 20 seconds for your answers. حتى ما حدا يفوت على جوجل يجيب لي اياها. يلا 10 seconds. اول 5 اجابات رح يكونوا هن رح ياخذهم. يعني السادس اجابه ما رح اعتبرها محسوبه. حتى تكون الاجابات سريعه بس هذا هدفنا. How to change from centimeter squared to meter squared. Okay, be sure it's private message للباقيين بس احنا حدا يبعتها مثل داني. The rest. Great. صار عندي 2 answers. 2 correct answers. 3 seconds, 2 seconds, 1 second. Thank you. No more need for the rest to send me any messages. أنا حاولت تكون سريعة بس لسبب واحد أنا هذا الشيء فيكم تجيبوه على الإنترنت
بس
بعرف.
سوري كنت ما كنت سامع شو السؤال،
ليه؟
كان عم بيقطر الصوت.
Okay. So they said that we have to multiply by 10 to the power minus 4. So 10 times 10 to the power minus 4, and the answer will be in meters squared. So it's going to be 10 to the power minus 3 meters squared. That's how we change from centimeter to meter square. They said that this coil, this flat coil C, which is the green one, okay, so as you can see on the figure, they said a flat coil C, 100 turns, each of area 10 centimeters square, placed inside a long solenoid S and connected across the terminals of a lamp L that glows under a small rated voltage. The axes of C and S are confounded, and each turn of C is oriented positively as shown in the figure. So as you can see here, the positive sense directed in this way. S is connected across the terminals of a generator. The direction of the current I carried by S is shown in figure 1. Figure 2 represents I as a function of time. That's the given. Identify the south and the north faces of S. So just tell me for the solenoid, where is the south pole and where is the north pole? If it's going to be on the left side, tell me the left side is north or the left side is south. Within one message.
Can you repeat the question?
Yes, it's part A. Tell me where is the north and the south of the red solenoid, depending on the current that you can see here. I'll wait for your answers. ما فيكم تبعتوا لي بس رايت او ليفت بس، يعني لو بعت لي كلمه رايت مثل داني او مثل امير انا يعني بدي كلمتين، بدك تبعتوا لي الرايت شو هو والليفت شو هو، مش كلمه واحده بس. اوكي جريت. مثل كيوان the left side is كذا the right side is okay. اوكي بلشنا عند كمال the fastest. امير اوكي great امير nice work. يلا the rest. رح انطر 10 seconds بس لحتى اخذ الاجابات، لان اذا بيطول اكثر من هيك بصير في نقل عن بعضكم. 5 seconds. 3 seconds. Time is over. Okay, let's check the rest. Ghiwa said that north is to the left and south is to the right, which is not the correct answer. Leanne said south is to the left, which is correct. يعني north هو راح يكون on the right. فعندي الإجابات الصحيحة كانت مع كمال، مع ريان، مع أمير. The 3 answers. Okay, how can we know the correct answer? Look please on the screen. If you try to use your right hand rule, the current is flowing from the top to the bottom of this S solenoid, the red one. So we have to point our fingers for the front side, the side that you can see with your face, by pointing your 4 fingers downwards and trying to rotate your 4 fingers. So if I want to draw this here on the screen, these are my 4 fingers, and this is the direction of my hand. Sure, it's going to be the right hand rule. I'm sure that Riwa used her, maybe she's using her left hand to get a different answer. So this one will be the direction of B. So here will be the north and here will be the south. Okay, if I want to draw it on the solenoid directly, so here the direction of I, this one will be the north pole and this one will be the south pole on the right side and on the left side. If there is any question, let me know please. So part A, right side, north pole, left side, south pole. sure using your right hand rule. If you have any question, let me know, please. Now we'll move to the second part, part B. I will wait seconds for this. They said that use figure 2 to specify the interval of time during which the lamp glows. So we have to specify a time interval for which the lamp will be glowing here. And now after I receive your answers for this part, I'm going to ask someone to explain for me why you chose this interval. So part B, specify the time interval for which the lamp will be glowing or the lamp glows.
استاذ بس ثاني فيك تشرح شوي السؤال كيف لان ما فهمته للسؤال بس لأعرف شو بدي كيف بدي.
Okay, if we take a look here on the screen. Seconds. Okay, as you can see on the screen, the green flat coil is placed inside the red solenoid. So in this case, once the current starts flowing in the solenoid S, something will happen within this green coil. So we have to specify the time interval using this graph. Between what time interval will the lamp start glowing or glows?
Okay.
Okay, I'm just receiving your answers for this part also. The first correct answer, yes, thank you. Second correct answer. Great. Third correct answer. And now I'm going to ask after a while someone to explain for me why you provided this answer. Yeah, 10 more seconds and I will stop taking your answers. Okay, that's it. Let me ask Kamal. Can you, Kamal, provide me your answer for this part? Why did you choose this interval?
لأنه ال I is variable between 0 and 2 seconds.
Okay, so if the I is variable, what will happen?
The lamp will glow.
Okay, can you give me the explanation step by step? You are totally correct, but try to give me the explanation step by step. First of all, the current starts increasing, then what?
Then it's constant.
Then it's constant. Let me just move to غوا before ريان. يلا غوا برجع ريان. Can you give me your answer غوا, why you chose this time interval between 0 and 2?
When I increases, it starts passing through the solenoid to reach the lamp in order to glow.
Okay.
Yes.
So you mean the current is flowing through the lamp, right?
Yes.
Okay, you got. Okay, ريان خلينا نشوف ريان قبل ما أعطي إجابتي أنا.
Yes, according to the graph between 0 and 2 seconds يعني it was the I was varying increased from 1 to 3.
Okay.
While from 2 to till 5 it remained constant at 3. Therefore when the time is variable when the I is variable then it's between 0 and 2.
Okay. Let me just ask one more question in general for all of you. The current, as you can see here in this figure 1, the generator is connected to the solenoid S, to the red solenoid, and not to the green solenoid. How can we explain that the current is flowing inside the lamp? So the generator G is connected to the red solenoid, not to the green one. How can we explain this? If you know the answer, just raise your hands. I'll wait a little bit for that.
Can you repeat please? الصوت عندي
Can-
ما عندي وقت.
Yes, I will just repeat the question. The generator G is connected to the red solenoid S and not to the green solenoid. So how the lamp is working, how the lamp is glowing? I'm not sure if you can hear my voice or not.
ما بعرف إذا من عندي أو من عندك.
It's very